Okay, so we are going to work on compound inequalities. And typically with compound inequalities, you'll be thinking about and or. So if we think about that, like x can be greater than 3, or it can be less than -2, for example. When you have an or, I'm going to go ahead and write that. So x is greater than 3, or x is less than or equal to -2. When you have an or, I am going to, like all the other graphs, graph my 0, graph my -2, and graph my 3. So x can be greater than 3, or x can be less than or equal to -2. So when you have an or, your graphs need to be going in opposite directions. For an and, your graph, let's say this is a -5 and this is a 1, your graph is going to have an overlap. So if I were to write this out, let's say x is greater than or equal to -5 and x is less than 1. So there's my 0, 1, and my -5. I'm going to do two different colors, so hopefully you can see the overlap. X is greater than or equal to -5. And x is less than 1. So you're looking for that area of overlap. So typically we would show it without all the other stuff on there and just show the 1, 0, -5, and just emphasize the overlap. Okay? Ands can either have the word and, or they might look like this. Okay, so when you are doing these, remember you are reading from the variable. So I'm going to be reading it the same way. X is greater than or equal to -5, and x is less than 1. So if it helps you by splitting it into 2, then go ahead and do that. Just make sure that you are not changing this and to an or. So if we have a compound inequality, such as let's get into some multi-step. So if we have -2 is less than 4x minus 8, which is less than 10. Now, is that an and or an or? You should have recognized that it's an and because an or has to have the word or. So when you have it written like this, and notice we don't just have one variable in the middle, we have several terms. These terms have to go with both equations or inequalities. So I would take the middle stuff and write that as 1, and then I would take the middle stuff again and then solve both of them independently. I'm going to add 8 to both sides and have 6 is less than 4x. Divide both sides by 4. Don't be freaking out because it's a fraction. So you have 3 halves is less than x. solve over here. I'm going to add 8 to both sides. 4x is less than 18. Turn around and divide both sides by 4. And x is less than 9 halves. Now, 9 halves might not be very easy for you guys to graph on the number line, but again, that is why we have the fraction button on our calculator. So over here, I am going to take these and write it as 1, because that's what my answer is going to have to look like. So 3 halves is less than x, which is less than 9 halves. I can do some conversions in my calculator and know that this is the same thing as 1 1/2 is less than x, which is less than 4 1/2. So I have 0, 1 1/2, and 4 1/2 on my number line. So I know that x is greater than 1 1/2 because I have to read it this way. X has to be greater than 1 1/2, and x has to be less than 4 1/2. So any of those values would work. So that is an and. For an or, you have to have the word or. So let's go ahead and try 17 is less than or equal to 2x plus 3. Or 2x plus 3 is less than or equal to 11. So just like the ands, we're going to solve the two inequalities independently. Subtract 3 on both sides. Divide both sides by 2. I am going to rewrite it so that my variable is on the left. So I had 7 is less than or equal to x, which means that x is greater than or equal to 7. Go back up to my other one. 2x is less than or equal to 8. Divide both sides by 2, so x is less than or equal to 4. I do not need to flip the sign because I am dividing by a positive number. So x has to be greater than or equal to 7, or x has to be less than or equal to 4. I graph those on my number line, always shows 0. X has to be greater than or equal to 7, so it's going to be closed because of the equal to. And x has to be, or x has to be less than or equal to 4. Another closed circle. Remember, ors, we do want to go in opposite directions.